Okay, now we're going to show how to model the baseball problem on our graphing calculator. I already put in the equations that we had done when we did the problem. Our x equals 150 cosine of 18 times t, and the y is negative 16 t squared. I think the negative is there. I need to go over here and double check. It is. And I did put in the um, little ball with a trailer down so we can actually see the ball flying through the air. If you didn't see the other video, you know you can change that to all those different things. What it's going to graph: a thin line, a fat line. This is a ball with a little trailer line that shows its path. You can also do the ball without the trailer line if you wanted to, where it doesn't have a line falling behind it. But I kind of like to see its path. So now we have to go to our window, make sure we can see the ball traveling. In this problem, we had already determined that it takes 2.8 seconds in order for it to go 400 feet. So we'll just say t goes from 0 to, I'm just going to say 4 seconds because that's fine. It could have went 3, it wouldn't matter. X minimum, -5. The fence was 400 feet from home plate, so let's go with 450 for our max. The Y minimum, we start -5. How high does the baseball go? Not really sure. Let's just let's go with 150 feet. Not sure what that'll be, but I'll make our Y scale 10 too. So that takes care of that. And let's just take a look and see what if our window is going to handle that now. Oh yeah, the ball doesn't go near that high, so we can we had put 150, so we can probably I would say put 50 feet for the height of the ball. Didn't go very high at all. So we'll change that to 50, and let's take a look at the graph again, and that'll work. Now, we were asked to see if it was going to clear the fence. So how in the world are we going to build a fence parametrically? Well, it's not that hard. It might seem a little hard at first, but basically we know that the fence has to be 400 feet from home plate. So that means if I'm going to draw that, I've got to say X is 400 and oops. So X is always going to be 400 and we want it to go straight up and down. So now if we were to plug in a T for Y, T is going to run from 0 to 4 seconds, right? So let's take a look at what happens with that. So now you can see right here, there's a little red vertical line there. The problem with that is though we were supposed to make it, how high was it? It was supposed to be 20 feet high. So let's go back to our window again and take a look. If we say, I'm sorry, to our Y equals, if T runs from 0 to 4 like it showed in our window, and that means that fence is only going to be 4 feet high. And since I went from 0 to 4 and I want the fence to be 20 feet high, so what do you think I need to make this? Well, since T goes up to a maximum of 4, if I put a 5 times T here, when T is 4, then the Y height will be 20. And let's sit and graph again. And there is that, and here's the fence. Well, you can see that it clearly didn't hit that, but I don't really like the fence coming in there afterwards. How can I get the fence to be there earlier or before? Well, we could make it to be the first thing we graphed, or I don't know if you know, in mode, you can go down here and hit, see it says sequential. We can go simultaneous, which means it'll graph both graphs at the same time. Let's take a look at that. So you can see there's the fence growing, and it did, it took a while for it to get up there. So if you wanted the fence to be there before the ball was hit, you would need to to plot that as your first equation. Another way, let's see. So um, we could go back into the y equals, and we could switch and put the uh, equation for the wall in x1, and then put the equation of the ball in x2, y2, and then that would make the fence be there before the ball was hit. But I'm not going to do that right now. You can do that if you want. One thing, going back to the graph again, if you hit trace, again, you can see the path of the ball. You can tell the ball where it is at any time t. If I say t is 1 second, we can see where the ball is at. It's 142 feet from home plate, and it's 33 feet high. If we go to 2 seconds, it is here, and here's your coordinates as to where it is. We were saying that it hit the fence at 2.8 seconds. So let's try 2.8. And we can see that right there it hits the fence. And the height is 7.347. Now, you can see that's like 7.35, which is what we'd said in the problem. But to be the most accurate, you would need all the decimals like we did on the paper. But anyway, that's pretty cool where you can see the path of the baseball. You can see that it did not clear the fence. And that's it.